For Algebra 2 1.5, we're dealing with inequalities. And there's two basic rules to inequalities that will just help you remember. In your book, they have all these key concepts, but I've broken it down to two important rules. The first one is when you're dealing with an inequality, that's an equation with less than, greater than, less than, equal to, greater than, equal to sign, you just need to treat it like an equal sign, okay? So treat the inequality like as if it's an equal sign. So what that means is when you're solving it, solve it like it's an equal sign. What you do to one side of the equal sign, you have to do to the other. What you do to one side of the inequality, you have to do the other. The only difference is when you get to rule number 2, is when you're multiplying or dividing by a negative, and it's very important, multiplying or dividing by a negative, not adding or subtracting, but multiplying and dividing, you need to take the inequality and flip it to the other side. Okay, so basically if I'm taking negative 3x is less than 9, and I have to divide both sides by negative 3 like I would with any problem, because I'm dividing by a negative number, not dividing a negative number, but dividing by a negative number, then I end up with x is greater than, I have to flip negative 3. Okay? Other than that, you just treat it like an equal sign in order to solve. Please make sure to write this down before or after I start talking, and then also remember your vocabulary. When we're graphing an inequality, and we're going to be graphing it on a number line, you might not quite understand what I mean by this, but just bear with me. When I'm graphing an inequality, if I don't have a line underneath that says equal to, I'm going to graph with an open circle. Okay? When there is a line underneath it, that means it includes it, and I'm going to graph with a closed circle, just basically bubble in. And then I have an arrow that goes one way or another on my graphing. Now this might not yet make sense, but when we do an example problem, you'll see what I mean. So open circle if there is no line underneath my inequality, and closed circle if there is a line under my inequality. My first problem is asking to solve for y is less than 5y minus 2. So 4y minus 3 is less than 5y plus 2. Then it asks me to solve. So first I'm going to solve it. I'm going to treat it just like an equal sign. So the first step is to isolate my y. So let's subtract 4y from both sides. I end up with negative 3 is less than 1y plus 2. My next is to do what? Subtract 2 from both sides. Okay, negative 3 minus 2 gives me negative 5 is less than y, because that one y is the same thing as y. And because I didn't divide or multiply by negative, I just subtracted, this is my answer. Okay. The problem is that when I want to graph it, it'd be better if my variable was on the left-hand side. So you see how this is on the right? All I need to do is when I bring it all over, so I'm going to switch it. Anytime you switch, on an equal sign, it doesn't matter which way you should switch. But in this one, if I want to switch and put y on this side, I have to flip the inequality. Okay? And you'll see why we're doing this in a minute. But in order I want to move the variable to the other side, I have to flip the inequality. So it means the same. That means y is going to be bigger than negative 5. Because remember, the open mouth eats, and that's an elementary school thing. The open mouth eats the bigger number. So here it's telling me that y is bigger than negative 5. So if I want to put y on the other side, it still means the same. Y is bigger than negative 5. If I don't flip it, then I change the whole meaning. Okay? So basically what this is saying is that on a number line, and we're dealing with just graphing one line, we're going to be dealing with negative 5. So if this is 0, negative 5 will be here. And is there a line underneath? Because there's no line underneath, I'm going to have an open circle. And here's the thing. because whenever the variable is on the left-hand side, all I need to do is see where it's pointing. You see how this is pointing to the right? All I need to do is then go that way. So what this is telling me is that my answer lies anywhere bigger than y, but because it's open circle, it means it does not include -5. It does not say greater than or equal to, it just says greater than. Okay? So again, the variable's on the left-hand side, so if it's this way, then I just draw the arrow that way. If the inequality is the other way, then I'll draw the, sorry, not the variable, I'll draw the line this way, and if it's flipped the other way, I'll draw it this way, so whichever way this is pointing. So it's important to have this on the left-hand side. Our next one is asking for the same thing. It wants us to solve 12 is greater than or equal to -0.3p. Okay? In this case, I'm going to divide both sides by -0.3. Okay? And if I take out my calculator, 12 divided by 0.3 is 40. So this is -40. But what did I do here? I divided it by a negative number, so this then flips. So instead of greater than or equal to, it's less than or equal to, and since these cancel out, I end up with p. Okay? So because it's on here, it flipped. And if I want to graph it, I'm going to put the variable on the left-hand side. Now, if you can graph it without flipping, that's fine. You're not always required, but for a lot of people, it's just easier. So if I want to put the variable on the left-hand side, which is p, I'm going to then flip it -40. Okay? But this ultimately is my answer. And I'm going to find -40, let's say right here. And because it's there's a line underneath, I'm going to do closed circle. And this is going to the right, so we're going to go right. So that means that p is anything bigger than -40, including -40. Your first problem, I forgot to mention, you're going to do page 37, number 2. Page 37, number 2. And then this one is page 37, number 6. So far it's number 2 and number 6. And we have one more example problem. This one, you're not going to have to worry about graphing. Let's see it here. It's 37, number 8. So let's just worry about solving this, not necessarily graphing. Okay, I'm going to treat this like an equal sign. Sorry. I'm going to treat this like an equal sign. The first step I'm going to do is multiply both sides by 2. This and this cancel out. 2 times -x gives me -2x. Okay? So when you see that fraction, just take the denominator and multiply both sides so that you don't have to worry about that fraction. X minus 7. Alright? Now I want to isolate it, so let's subtract x from both sides. We end up with -3x is greater than -7. Okay? On this case right here, I'm going to, my second to last step is to divide both sides by -3. Okay, what did I just do? I divided it by a negative number, so therefore I'm going to be left with x, but I'm going to flip the inequality this way. Okay, and these negatives cancel out, so instead of having -7 over -3, I have positive 7/3. So my answer, and just leave it in fraction, x is less than 7/3. So your last problem is to do page 37, number 8. Don't worry about graphing it, just graph the other two, but this one, I just want you to go ahead and solve it. So x is less than 7 thirds. So you have number 2, number 6, and number 8, and bring it to class. Don't forget your vocabulary. I'll see you tomorrow.